Lesson 2 is some geometry review, and mainly we'll be talking about angles and then polygons and some specific types of polygons such as triangles and quadrilaterals. Now in geometry there are a lot of definitions that are important to remember. I'll quickly go through a lot of these different definitions, but it's up to you to memorize them. And so what I'll do, any of the words that you see in red on the board, those are definitions that you need to memorize. And you might want to just list those on a separate piece of paper and write out what each definition means. Now in the previous lesson we discussed lines a little bit, and some other properties of lines are if you have two lines that never intersect, those are considered parallel lines. Two lines that do intersect, those are considered intersecting lines. And where they intersect, angles are formed, and we can identify angles by little tick marks, we call them. Now there are a number of ways, an infinite number of ways actually, that two lines could intersect with each other. One that's real specific is when they're straight up and down compared to each other, or perpendicular to each other. That example that I have there, those are perpendicular lines. And to know that they're perpendicular, like if you had two lines on a piece of paper and they said those are perpendicular, well, it's hard to know if they're exactly perpendicular or not, because just you can't tell for sure maybe. So a little box is drawn on one of the corners there, and anytime you see that in a math textbook, you know that that means those are perpendicular lines. They are at right angles to each other. So lines can be parallel to each other. They can be intersecting, just regular intersecting lines. They can be perpendicular. Perpendicular, those are lines that intersect at right angles to each other. And let's just draw what a right angle is. We can always draw an angle by two rays, and then where their endpoints connect together. And so we would identify that as a right angle by a little box on the corner. Now a right angle, that has a measure of 90 degrees, and you always measure an angle. You can start at the bottom and move over. That distance there, that is equal to 90 degrees. So that's how you always know something's a right angle, is that it's equal to 90 degrees. Now if you had two right angles that were back to back, then you would have a straight angle. And so a straight angle, and we can always tell it's a 90-degree angle or a right angle because of the box on the corner. A straight angle has a measure of 90 plus 90, so that would be 180 degrees. That's the measure of a straight angle. Now those are two types of angles that have specific measures to them. An acute angle, all that is an angle that is less than 90 degrees. And so in that intersecting line example that I have there, the two smaller angles, both of those are acute angles. And just so you know, it happens that when you have two intersecting lines, those angles opposite to each other are equal. Sometimes they're called vertical angles. So both of those little angles are the same, and they're both acute angles. Now I've put the green tick marks on those intersecting lines. Those two are obtuse angles. Those are greater than 90 degrees. So four types of angles are right angle, which is equal to 90 degrees, straight angles, which equal 180, acute angles, which are less than 90, and obtuse angles, which are greater than 90 degrees. Well, now let's go ahead and talk about polygons a little bit. Polygons, those are defined as simple, closed, flat shapes that are all their sides are line segments. So let's just think about that. Simple, closed, flat shapes whose sides are line segments. If it's simple, that means that nothing intersects. So that would be a polygon. That is simple. It's closed. This would be an example of open. So you can see the difference between open and closed. Flat, if you draw them on a piece of paper, they'll be flat. and then their sides are line segments. So this would not be a polygon because one of its sides is not a line segment, it's a curve. And then this, even though its sides are line segments, it would not be considered simple because the lines cross each other. So in those examples, the one I'm circling, that's the polygon. The other ones, they don't fit the definition of a polygon. Now polygons, they are named based on their number of sides. And their number of sides is also the same as their number of angles on the inside. That's where polygon comes from. Poly means more than one or many. Gon means angle, so many angles or more than one angle. That's what these shapes have. If you're using the Saxon textbook, on page 5 there's a table that talks about the names of some different polygons. Like a 3-sided polygon is a triangle, a 4-sided is a quadrilateral, 5-sided is a pentagon, and so on. You should know at least through a 10-sided polygon. 10-sided is a decagon. That'd be good to memorize all of those because you'll hear about those throughout the book. So if you don't know what an octagon is, maybe you have a problem in lesson 30 about an octagon. You have to go back to this lesson to remember what an octagon is. So try to memorize those, and that'll just make your math a little bit easier for you. Now it's important to know what a concave and a convex polygon are. The way you can tell the difference between them is a concave one. If you can draw a line segment somewhere and it goes outside the polygon at some place, then that's a concave polygon, just like I did there. Now on the one on the right, we can't do that anywhere. We can't draw a line segment that has its endpoints inside the polygon but then goes outside the polygon at some point. So the one on the left is a concave, the one on the right is a convex. Now I've drawn two more polygons, two quadrilaterals. They both have 4 sides. One of those is a regular quadrilateral and the other one is not. Regular quadrilaterals, they have all of the sides the same length and all of the angles inside are the same measure. So this regular quadrilateral, all those angles, those are all 90 degrees. So regular polygons, they have all the sides and all the angles the same length. They may also be called equiangular polygons or equilateral polygons. If all their sides are the same length, then all their angles have to be the same length as well. So it's just by definition, then they would be a regular polygon as well, because regular polygons have all the sides and all the angles the same length. Let's talk a little bit more detail about two special types of polygons that we look at a lot, triangles and quadrilaterals. There are several types of triangles that are important to know about, and some of these are real similar to angles that we've already studied. They have similar names. For example, we know what a right angle is. We represent that by the little box at the corner. That lets us know that that is a right angle and its measure is 90 degrees. We can just add another segment right there, and now we have a right triangle. And in the same way, we can make an acute triangle. If it has one of its measures is less than 90 degrees, that can be an acute triangle. Actually, all of its measures, all of its angles would measure less than 90 degrees. An obtuse triangle, just one of its angles has to measure greater than 90 degrees. And so in that example, that would be this angle right here. That would measure greater than 90. And so that's an obtuse triangle. And then an equilateral triangle, or equiangular as well, all 3 angles are the same measure. Let's talk about an equiangular triangle a little bit more. Now, if all the angles are equal to each other in an equiangular triangle, what are they equal to? Well, hopefully you remember that the sum of the angles inside a triangle, that always adds up to 180 degrees. That's a very important thing to remember about triangles. The angles in a triangle add up to 180 degrees. So knowing that, there's 3 angles in an equiangular triangle, as there are in any triangle. There are 3 angles, so we can just do 180 divided by 3, and we would find that each angle is equal to 60 degrees. And so we could just put 60 degrees, and then we'll put green tick marks on the other angles as well. Since we put 1 tick mark at each place, that represents all 3 angles are the same. If one of those we would have represented it with maybe 2 tick marks or 3 tick marks, then that would tell us that that angle was different. So the tick marks, those just help us identify similar angles, or we could use that to identify similar sides as well. For example, let's talk about some triangles that have side relationships. One of those is called an isosceles triangle. In that, 2 of the 3 sides are the same length. Iso means same. The scales part, isosceles, the scales end, that means legs or lengths, similar lengths. An equiangular triangle is also an equilateral triangle. All of the sides are the same length, so we could represent that by tick marks, all 3 sides with 1 tick mark on them. That tells us that they're all the same length. Now a scalene triangle, that one, no sides are the same length. And so for that one we can put 1 tick mark here, 2 here, we could put 3 on the bottom one or leave it blank, because either way that represents that that side is different. I'll just go ahead and put 3 marks on there. So make sure you know the difference between those 3 types of angles or triangles in terms of the lengths of their sides. Well, now that you know some things about triangles in terms of their angles and sides, let's go ahead and do some practice problems. Look at practice problem A. There's a triangle there. You've been given that 2 of the angles measure 47 degrees. What is the measure of angle A, that one at the top? Well, just think about what I have written at the top of the board there. Angles in a triangle add up to 180 degrees. So to figure out A, we would say A plus 47 plus 47 is equal to 180 degrees. So we have those 3 angles, A, 47, and 47. We know that those have to total up to 180 degrees. And so now we can just figure out what A is. Let's just simplify. A plus 47 plus 47, that would equal 94, is equal to 180 degrees. Well, now we think, what plus 94 would give us 180? Well, if we subtracted 94 from 180, that would give us what A is equal to. And so, if you remember addition and subtraction, when you have a missing value like that, you can just subtract the same amount from both sides of the equal sign, and 94 minus 94, that's 0 there, and so then you can get A is equal to, let's just go ahead and do that subtraction. We'll need to borrow 1 from this 8. We'll have 10 minus 4 is 6, and then 17 minus 9 is equal to 8, 86 degrees. So that's what A is equal to, and we'll put a box around that answer. Look at practice problem B. On this one, we've just been given one angle. The one on the bottom right is 30 degrees, and we want to find what angle B is equal to. Well, there's got to be some other information there to tell us how to solve this problem. In practice problem A, that was pretty easy because we knew 2 of the 3 angles, so we just had to subtract from 180 to figure out A. But look at this. We have an isosceles triangle, so we can see that we have 2 sides that are the same length. And we also see that the 2 green tick marks on the angles, that tells us, since those are both 1 tick mark, that those angles are the same. That's an important thing to know too, that angles opposite similar sides, those are equal to each other. So in an isosceles triangle, the angles opposite those 2 sides, those are equal, and so that means the one on the left, that's 30 degrees as well. So now we have 30 and 30 is 60. Let's just do this problem in our head. To figure out B, we have to think, well, 60 plus what would equal 180? Well, 60 plus 120 would equal 180. So B is equal to 120 degrees. Let's do one more problem with triangles. In this one, we've been given the obtuse angle. That's 134 degrees. Remember, an obtuse angle is greater than 90. So this is an obtuse triangle, since at least one angle is greater than 90. Acute triangles, all of the angles are less than 90. Two of the sides we've been given. Those are 15 each. And so we know it's an isosceles triangle. We know that angles opposite similar sides, those are equal to each other. So that means that angle C and angle D are equal to each other. So sometimes that little symbol there is used for angle. We can say that angle C is equal to angle D. Okay. Now we know that the total angles in a triangle add up to 180. We've been given that the obtuse is 134. So if we did 180 minus 134, that would tell us how much C plus D equal. Another way to write this problem would be C plus D plus 134 is equal to 180. Let's just continue with our subtraction. We need to borrow 1. So we'd have 10 minus 4 is 6, 7 minus 3 is 4. 46 degrees is what C plus D is equal to. Now since those two are the same, we can just divide by 2. 46 divided by 2 is equal to 23. And that's what C is equal to and D. Both of those equal 23 degrees. Make sure you know the definitions of triangles based on their angles and based on their sides. That you know that the sum of the angles inside is always equal to 180 degrees, and that for isosceles triangles, those angles opposite the two similar sides, those are equal to each other as well. Briefly, let's look at some more definitions of quadrilaterals in this case. This is a specific type of polygon, and one of those is a parallelogram. And in a parallelogram, the pairs of sides, those are parallel to each other. And so let's just represent that by tick marks. Those two sides are parallel, and these two sides. So a parallelogram has two pairs of parallel sides. A trapezoid, that just has one pair of parallel sides. So we'll represent those by one tick mark on each of them. They just have one pair of parallel sides. A rectangle, it's like a parallelogram in that it has two pairs of parallel sides. The difference between it and just a regular parallelogram is that all of the angles inside are right angles. Another one is a rhombus. That's also like a parallelogram, except all of the sides are the same length. So we represent that by one tick mark on each one. And then lastly is a square. That's like a rhombus with all the angles right angles. So that means all the sides are the same length like a rhombus. All the angles are right angles though. Make sure you know what each of those definitions of quadrilaterals are, and sometimes you play little games with the different definitions. For example, look at practice problem D. Is a parallelogram also a square? It's important to know the definitions in order to answer a question like that. For example, a parallelogram, by definition, it just has two pairs of parallel sides. A square, it has two pairs of parallel sides that are the same length, and that also all of the angles are right angles. A parallelogram does not have to have all the sides, both pairs of sides the same length, and all angles right angles. So a parallelogram is not necessarily a square. Now a square though, if you reverse that, a square is always a parallelogram though. So the answer here is no. You could complete it, make a further answer to that. You could say no, but a square is a parallelogram. So it doesn't work both ways. A trapezoid is always a quadrilateral, but a quadrilateral is not necessarily a trapezoid. Just make sure you understand the differences in how each of those types of quadrilaterals was defined. Okay, well that's all for lesson 2.